Okay, good evening again. This is Professor David J. De Los Reyes. Okay, my topic for this session will be the derivation of the quadratic formula under algebra. Okay, let's proceed. We got a problem. Derive the quadratic formula. We are given the quadratic equation ex squared plus bx plus c equal to 0. We are given the quadratic equation. The highest power of x is actually 2. That's why it is quadratic equation. Okay, let's try to derive the quadratic formula. Actually, the quadratic formula is this one here. X equal to negative b plus or minus square root of b squared minus 4ac over 2a. Actually, this was derived by using Maclaurin series of... No. By completing squares. I'm thinking of advanced mathematics. Sorry for that one. This was derived by using completing squares. Okay, let's proceed with the solution. I will rewrite the quadratic equation, the ex squared plus bx plus c equal to 0. Okay. We will algebraically manipulate the given quadratic, okay, for us to complete square. We transpose this c here to the right hand side. So actually, it was something like this. It is minus c equal to minus c. So this one here cancel with this. Okay? Ex squared plus bx, and this should be equal to minus c. That is after the transposition or just simply subtracting negative c to both sides, right? Then after that, we will try to multiply all the terms by 1 over a. Right? So ex squared times 1 over a, this a here cancel with this. What remains is x squared. Bx times 1 over a, the coefficient of x will be the ratio b over a times x. And this should be equal to negative c times 1 over a will be negative c over a. Okay, after that, we will complete the square. To complete the square, okay, we will take 1/2 of the coefficient of x, then we will square that one, then we will add that one to both the left and right. So I will present it here. The coefficient of x is actually b over a. I will take 1/2 of that. Then I will square that one. So what comes out will be b over 2a quantity square. Then I will perform the operation. I will add that to both sides of the equation. What you will do on the left, do it on the right, right? So completing the square. So x squared plus b over a times x. Okay? I will add this one to the left hand side, and this should be equal to negative c over a. And same, I will add b over 2a quantity square. Because this one here actually cancels this, but we could do it. We could add it, right? After the addition of b over 2a quantity square, the left hand side is now factorable to the quantity x plus b over 2a quantity square. Okay? And this should be equal to negative c over a. I will take the square of the b over 2a now, b squared over 4a squared. For the left hand side, x plus b, what do you call this? Over 2a. Quantity square. Actually, if we try to take the square of this is the square of a binomial, right? So the first term will be the square of x, which is x squared. The middle term will be the product b over 2a times x times 2. So this is 2 times b over 2a times x. That's the middle term. And the pure constant term will be what we added a while ago, 4a squared over 4a, b squared over 4a squared. because these two here cancel with these two here. So what remains will be x squared plus b over a times x plus what we added the value of b squared over 4a squared. Okay, we added this one for it to be factorable to this one, right? So meaning to say the factor form of this one will be the quantity x plus b over 2a quantity squared equal to negative c over a plus b squared over 4a squared. Okay? Okay, I will try to show you another simplification. The y inside the radical. If we try to compute for the value of x, okay, we will raise both sides of the equation to the 1/2, right? So x plus b over 2a quantity square raised to the 1/2. 2 times 1/2, these two here cancel with this. So what remains will be simply x plus b over 2a, right? And for the right hand side, we could not do anything yet on the right hand side. We will just follow as it is. So this will be the square root of minus c over a plus b square over 4a square. Okay? I will try to remove this one. Okay? Let's try to simplify the one inside. The one inside, we are adding two fractions with different denominator, right? So if we try to simplify this one, the resulting numerator will be the product of ab squared minus 4a squared c, and the common denominator will be the product of the first and second, which is 4a cubed. And if we try to simplify this one, okay, it can be written as a times the quantity b squared minus 4ac over a times 4 times a squared. Actually, this a here cancel with this, right? So what remains will be b squared minus 4ac all over 4a squared. Then if we try to take the square root, sorry for this one. If we try to take the square root, it will be b squared minus 4ac. But 4a squared is a perfect square. So actually we could bring out this 4a squared. The square root of 4a squared will be 2a. Right? So if we try to continue this one, x now will be equal to, we'll transpose this to the right. This will be negative b over 2a plus or minus, okay, the square root of b squared minus 4ac over 4a squared. But the equivalent of this one now is this one, right? So it will be x now will be equal to negative b plus or minus the square root of b squared minus 4ac. Okay, this is 2a, this is all over 2a also, because we brought out already the square root of 4a squared, which is 2a. So this is under one common denominator, 2a. So this is actually the quadratic equation. That is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, that's it, guys. That's the derivation of the quadratic formula by using completing squares. Good evening from Los Angeles.